So welcome to Unix CBT PF Firewall Edition or pFirewall Edition. Let's have a look at some of the features that are applicable to this wonderful firewall framework. In particular, we'll be looking at pFsense, which gives us a full framework for the management of our firewall system. So let's just label this Unix CBT since it falls within BSD Unix and is premised upon PF, which is inherent in the BSD implementation. So Unix CBT pFirewall Edition. And let's talk about in this section the myriad features that are accompanied with this particular firewall. So pFsense is certainly a modular firewall. And by that we mean, of course, like with any modular application such as Apache, you can extend it so it's extensible. You may include plugins that extend the capabilities of a firewall, providing various features. Now, by default, pFsense includes a number of modules which provide extensibility. Examples that come to mind include TCP dump, or maybe traceroute ping, or maybe add-ons such as Nmap, and the list goes on. Or maybe even RRD graphs, which track utilization across the system, key system metrics such as CPU and network interfaces, and so on. So essentially, pFsense is an aggregation, as all things open source nowadays tend to be, of a wonderful toolkit and ancillary modules that can help you to implement a fully featured firewall without having to go the commercial route. So it is modular. It is considered a commercial grade stateful firewall. Nowadays, firewalls are stateful, so even indicating that it's stateful is unnecessary. But nonetheless, it is a commercial grade stateful firewall. And let's just choose the hyphenated version, of course. This utility spell checks automatically. And in terms of using pFsense, there is a license disclaimer. So license disclaimer, it can be used for commercial purposes, but it is advised that you reference the pFsense license disclaimer, which can be found at About pFsense in the legal section. So let's just pull this link in. Essentially just ensures that credit is given to the developers of this wonderful facility. So let's get an instance of our browser going and just pull that up quickly to give credit where credit is due, because again, this is a wonderful aggregation. It's always been possible to run commercial strength firewalls from Unix. That's not a question. However, the way it's pulled together with pFsense is rather unique and works pretty well. Let's see what's happening here with our NIC configuration. Let's get a shell instance going. And this appears not to, well, actually, let's take a look at our resolve conf, see what's happening. So 75.1, it should be finding it. Let's do a dig google.com, see what's happening. That looks good. So let's try this out again. Let's just go to pFsense. Actually, we're missing the domain, obviously. So pFsense. And that should be it. So this is a license description. So if you do use pFsense, certainly consult this page. And you can modify pFsense, redistribute it, etc., so long as you keep the license disclaimer as part of whatever distribution you ultimately come up with that's derived from it. And that's all spelled out in this particular section. So have a look here. This product includes software developed by the pFsense project for use in the pFsense software distribution. And certainly, Unix CBT pFirewall Edition uses the pFsense firewall. So we just want to be careful to include that disclaimer. And again, pFsense itself relies upon the underlying PF firewall, which is included with BSD Unix, along with a number of other components, which allows it to be modular, as we've mentioned. So pfsense.org, about pFsense, take a look at the legal page. Let's continue with features. As we've mentioned, it's based on BSD. Unix in particular, FreeBSD, but there are components that are brought in from other instances such as OpenBSD. But for the most part, it's based on FreeBSD. So if you want to implement pFSense, let's say in a laboratory environment, you'll want to, and perhaps in a virtualized environment, you'll want to consider how to provision your virtual appliances for FreeBSD support. So this impacts, let's say, virtual implementation, which essentially means provision as if FreeBSD system when provisioning it. Now, certainly there's a live CD we can use to boot and use the firewall, ready to run directly from the ISO image. But if you decide to commit pFSense to the file system, then you'll want your virtual appliance to be based on FreeBSD. One of the interesting features that makes pFSense ready for the commercial scenarios such as enterprise environments is the fact that it's managed entirely via the web. So unlike, say, IP tables or even pF included with FreeBSD, this package is entirely managed. So managed entirely via the web, via a utility called Web Configurator, which provides the web front end. And that's important because it allows you to manipulate the entire firewall without having to know BSD Unix or Linux for that matter. The base provisioning of the pFSense firewall requires some knowledge of perhaps implementing virtual appliances or setting up operating systems on hardware. But apart from that, there is no need to know BSD or Linux or commands. So let's just note that this obviates the need to be intimate, let's say, with BSD Unix. So if you're considering for an enterprise deployment pFSense in lieu of, say, more traditional commercial firewalls such as Cisco, Juniper, and so on, then it's reassuring to know that you can manage the entire firewall via the web, providing you've provisioned the pFSense firewall on an appliance or on a physical appliance, so virtual or physical appliance. And certainly appliances are available for sale via the pFSense website as well as via third parties, so you can buy ready-to-order pFSense distributions as well. So let's just note, and perhaps that's a feature we'll list independently. So 5, that pFSense appliances, and of course these are hardware appliances, are readily available for purchase via pfsense.org and others. So these are, of course, common platforms such as x86, 64, which include pFSense, FreeBSD, a full stack ready to go with n number of interfaces rated for X amount of traffic. So includes a variety of interface configurations and supports a range of simultaneous connections. So obviously the larger the appliance, the greater the throughput, the more firewalling, filtering, VPNs, and so on will be supported by a particular grade. And you'll find hardware appliances from just a few $100s US up to the thousands depending on size. So obviously that matches any enterprise scale. So from the smallest of shops to the largest of shops, pFSense can entirely replace your Cisco, Juniper, or otherwise maybe Huawei or other implementations. So you manage it entirely via the web configurator front end, and that's very good to know. Now, just the ISO image itself supports, if you intend to implement it via software, perhaps within a virtual environment or on a piece of hardware. So apart from buying dedicated pFSense appliances, physical appliances, if you just plan to use the software, various images are provided for the various target platforms. And the common platforms nowadays include AMD 64, i386, as well as embedded. There are many such implementations, as well as just the live CD, which allows us to get or become more familiar with pFsense. So you may think nowadays we default to AMD 64 implementations. This is fine. This build is available, but currently, as per the documentation, the i386 is considered the most popular. And that's perhaps largely because firewalls generally don't require more than, say, a gig or two of memory, even for perhaps hundreds of thousands of simultaneous connections. So certainly with the i386 upper limit of 4 gigabytes, sans, of course, PAE or address extensions, you should be able to support even the largest firewall. So the 32-bit version is the most popular currently. But this doesn't preclude you from downloading the AMD 64 sources and deploying it within an AMD 64 hardware or software virtual platform. So just go with whatever you're comfortable with, whatever provisions you have available. We'll use the 32-bit version and deploy it within VMware, and it'll work just as well as the AMD 64 version. But a variety of images are available. So if you have embedded hardware, if you just want to try out the live image without committing pFsense to a particular file system, or 32-bit, 64-bit platform support. Now, in terms of specific features, let's talk a little bit about the common network-related features supported by pFsense. So certainly network address translation is supported. So network address translation. Virtually all firewalls support this functionality, as it allows us to conserve the IPs, the scarce IPv4 addresses, even RFC 1918 addresses. And a variety of methods are supported, including incoming NAT. So that means traffic sourced from the outside, needing access to resources on the inside, flow through the incoming NAT table. This is, of course, supported by IP tables as well, so it isn't unique to pFsense. But any firewall nowadays will support NAT without a doubt, incoming NAT, as again, you want to conserve the outside resources, publishing just those items that are necessary, such as the ports 80, 443, SSH, SMTP, etc. So outside clients, let's say, requiring internal resource access. And examples include HTTP, HTTPS, SSH, and the list goes on, SMTP, etc. And certainly for your internal resources needing outside access to the internet or to other subnets, there's outgoing NAT. So inside resources requiring, let's say, outside access, and outside could be other subnets under your auspices or the internet proper. It's usually referred to, of course, the internet for the conservation of IP addresses, IPv4 addresses. And also mirror or reflection support for NAT. And this allows access to NAT external addresses by internal nodes, so reflection. So access NAT external address from the inside. So let's say on the outside you've routed, let's say, HTTP or DNS or some other key service using a routable address on the internet. Your inside clients without split DNS or hosts entries or some other mechanism would normally request access using the outside address, which many firewalls would block. With reflection, the firewall provisions rules to allow internal clients to access internal resources using external addresses. So access NAT external addresses from the inside, essentially effectively accessing internal resources using external addresses. And that's mirror NAT reflection, which is supported. It's not enabled by default, but is supported. So those are your key NAT features: incoming, outgoing, and reflection or mirror NAT. Certainly DHCP is provided, and this includes both perspectives, so client as well as server. So the external interface can use, of course, a DHCP client agent to obtain its address in the event that it's plugged into your ISP's drop point. And it supports a variety of protocols, including PPPoE, just basic DHCP, and the like. You can consult the interface to see what protocols are supported. And if there is a protocol that isn't listed, chances are there's a module that will allow pFSense to talk that protocol. So virtually any type of external client that obtains an address using plain DHCP or PPPoE or other mechanisms can be supported by pFSense. And of course, it provides a server to supply addresses, both external and internal access. So by default, your LAN interface will have a DHCP server instance, which will supply addresses to connecting clients, as routers tend to do, or these types of systems tend to do. So expect standard DHCP client and server functionality. There's also DDNS support. It has a DDNS client so that you can register the latest address that the external interface has with, let's say, an internet public or private DDNS compliant server such as Bind and so on. And there's a list of DDNS servers, publicly accessible servers, that are included as part of a pFSense configuration to register your external address as it changes. In terms of filtering, expect common L2 through 4 filtering. So you can filter based on, say, MAC addresses through TCP, UDP ports, SCTP, etc. That's common, with the key filtering performed between layers 2 and 3, usually source IPs, destination IPs, and optionally layer 4 based filtering. And that's what a firewall should provide. And again, it's a stateful firewall, so it requires fewer rules to permit traffic, so long as the traffic can be tagged as related. So the firewall should allow traffic to pass, and that's what stateful firewalls are good for. Connecting or correlating sessions, so client requests to server responses. So you don't have to write as many rules usually with these types of firewalls. pFSense also supplies us with time-based filtering. This is a nice feature to have, and this can be accessed via the firewall menu, via the schedules submenu. And typically schedules are independent objects that are subsequently tied to various firewall rules. So independent objects that are tied or connected to firewall rules. So you can define a schedule that suits access or block, pass or deny, and apply it to the rules that should pass or deny, or pass or block or otherwise. And pFSense will honor those schedules accordingly. Sometimes it's appropriate to disable access, perhaps because of maintenance or otherwise. Well, scheduling certainly provides that capability. Aliases are also supported. Now, what are aliases? This gives us essentially references to various types of objects. Those objects include hosts, networks, ports, and essentially this simplifies rules administration, especially with respect to changes. So, for example, you could define aliases, let's say an alias, let's say IE DB servers. And this could be a group of DB servers or DBMS servers. And apply a rule to the group or to the alias named DB servers, which applies to all of the hosts within that group called DB servers. And similarly, you can group together networks as well as ports. Maybe you have a list of ports, maybe web ports or web server ports, and perhaps that list includes TCPs, let's say 22 for administration, 80 and 443 for web access, and so on. So the ability to assign names to a variety of resources simplifies administration. We can then tag rules to those aliases, simplifying administration altogether. So aliases simplify administration by allowing grouping and tagging to various rules, typically firewall rules, so various firewall rules. So it's a nice feature to have. And many firewalls support some form of aliases, a means with which to group nodes that are similar. And commonly, with resources that are published on the net, there are similarities. Again, common ports, 2280, 443 SMTP, etc., that need to be available across those hosts. Just makes it easier to group them and write rules that are tagged to the groups as opposed to the individual hosts. And that way, as you grow, let's say your web farm, database farm, middleware farm, etc., you simply update the group membership to include the new IPs, and they'll automatically have those rules opened or published to perhaps externally accessible IPs. Now, at its core, pFsense is a router, so it does provide routing, and this can be provided without firewall filtering. So routing services, common routing protocols like RIP, OSPF are supported, so common protocols. And routing can be performed or provided sans firewall filtering. So if you simply need a router, pFsense serves as a base platform. It uses the BSD routing engine, and in the event that you require subsequent services such as firewall filtration, VPNs, etc., you can enable those as well. So common examples include the deployment of cloud stacks or OpenStack cloud farms or CloudStack or any platform you go with. But whenever deploying considerable amounts of virtual resources, it's often desirable to have a software layer router available, which the stacks will provide, such as OpenStack, CloudStack. However, if you need an independent third-party router, pFsense will use or will provide those capabilities using the BSD engine for you, so you can treat it or implement it squarely as a router without any firewall filtering or VPN or other types of services. Another firewalling rule or firewalling feature that's provided is OS fingerprinting filtering, which can be defined as a rule. So you can grant or deny access based on OS fingerprints. This is a neat feature. So pFsense are able to determine the operating system that's making the request based on the way the request is formed and determine whether or not the traffic should be passed. So obviously this gives us the ability to pass or deny based on source, basically the client OS, so i.e. Windows, perhaps pass access to a particular port or deny or otherwise. So not only are we able to filter, and this is an application layer filtration feature at layers 2 through 4, but all the way up through the stack to 7 as well, which extends the capability of pFsense. Again, it's modular, so whatever the kernel is able to process, which is all of the layers of the OSI, some sort of module can be built and plugged into pFsense to extend that capability. And so far as cryptographic services for security, certainly VPNs are supported, so VPN support. Your common VPN protocols are supported. PPTP, which is more or less deprecated, but still supported. Any of the services that are available that provide, let's say, secure browsing will still support PPTP because it is the default client included within Windows, and Windows is still the dominant desktop operating system. So pFsense supports PPTP with some caveats with respect to how external IPs are used. So with, let's say, external IP caveat, caveats is attached, and the documentation covers those caveats in terms of how the IP resources may be used in the event that there are PPT clients behind your firewall or outside of your firewall, or PPTP servers outside or servers inside, etc. So PPTP filtering can be problematic, and those caveats are spelled out, but nonetheless, pFsense supports PPTP firewalls. Certainly IPsec and SSL via OpenVPN are two other common means of forming VPNs that are supported by pFsense. Another feature that's supported that makes pFsense a wonderful application, let's say for any type of application whereby disclaimers must be presented and accepted and so on, such as usage in public spaces like hotels, business centers, airports, and so on, is captive portal. This gives us the ability to force users to acknowledge or to act, perhaps legalese, prior to usage. So we have a mechanism which will force clients through our proxy, if you will. Captive portal also provides support for authentication via common protocols, including a local database, which is a default, and optionally radius. So wherever your users are defined, captive portal can be configured to find and authenticate them. And other features such as session timeouts are supported by captive portal. So if you think in the case of a hotel whereby you're granted X amount of hours, maybe 24 hours to use a service before force renewal, or perhaps a generation of a new password, forcing the disclosure of that password, captive portal is a solution for you. So if you're looking for a solution to deploy in your organization, say hotel, public space, airport, etc., have a good look at pFsense, as it provides these capabilities out of the box with no extra expenditures necessary other than your time to configure the features. And there's a reporting engine, so we can see all sorts of information about the current behavior or usage, system usage of pFsense. For example, we can have a look at the aggregate throughput. So we can see how much traffic is moving through our interfaces to get a sense for whether or not we're overtaxing the system. If the interfaces are, say, fast Ethernet and we're close to those limits, or gigabit close to those limits, then it may warrant the provision of additional interfaces or more capable interfaces, etc. Per interface throughput. So that still gives us the ability to determine whether or not individual interfaces are overtaxed or underworked or otherwise, or even problematic. Certainly CPU utilization. Again, any router is just a computer, so the key components, CPU, memory, network, disk, are always of concern. And there are other reports such as historical and real-time. So you get RRD logs for historical display of throughput, CPU utilization, memory utilization, and also real-time information, resulting in close to real-time. It's not actually real-time, it's close to real-time, because the AJAX, the web interface uses AJAX to refresh the screen often, so it's close to real-time, and it gives us metrics as close to real-time as possible concerning the behavior of your firewall. A lot more features are included with this wonderful firewall. For example, high availability with CARP. So you can configure failover, for example, if you have multiple pFsense instances deployed. So if one fails, the other will take over traffic. You may also configure load balancing. Server farms using a variety of mechanisms, common mechanisms, such as sticky persistence. And we've already mentioned that it's modular, it's extensible. Let's just reiterate that pFsense is extensible via packages, and a list of packages are included And there certainly is commercial support. As we've mentioned, you can obtain pFsense as a hardware appliance, which will come with commercial support, so available as hardware appliance from pFsense store. And support contracts are also available. So pFsense gives us a fully featured framework for managing edge services on our network. No need to use commercial services. This is essentially a commercial service. It gives you everything a commercial service would. Let's go ahead and update our documentation. We'll just call this Unix CBT P Firewall Edition Notes. Of course, it's included as usual. And that's set. And we have a default architecture, which we'll be looking at before we begin our studies in the subsequent section, but we just wanted to introduce you to the capabilities. Again, PF Firewall is included with BSD. We've covered PF Firewall somewhat in various editions of Unix CBT BSD edition. However, pFsense extends considerably by aggregating common components, including the core PF Firewall itself, as well as ancillary components, including web configurator and other modules, to make this wonderful framework that rivals any commercial firewall. It's being used more and more often across the world, as it is reliable. It's as reliable as your BSD instance, which is as reliable as pretty much any firewall appliance. So let's move on to actual usage after we've studied the architecture.